introductory dude here, just remembering that I'd never completed this question. So thanks Kurt Bonello for letting me know about that. And I'll just get this done. So we've done part I, which you can see in the force of interest video part 1. And now looking at part 2. So it wants to know what is the present value at t is 0, so that's important, of a payment stream paid continuously from this time under which the rate of payment is this amount, whatever that is. Okay, so how do we find that? Well, we know the present value, we can use that formula, is between whatever times we need, let's say, well, time 10 and time 12, and we have some payment amount, rho of t, and our discount amount, discount factor there. So that's what we're trying to solve over here, so I'll just get to work on doing that. So that is equal between 10 and 12 of 100 e to the, that's a positive, 0.03t times a discount. Now, we're looking at a time 10, which so happens to be above time 9, so we can use this, and this is going to discount it back to time 0 because we multiplied it times v of 4 and v of 9 in the last video to get this one. So because we are bringing it back to time 0. So this is being brought back just 2 years, and this is going to be brought back, bringing those 2 years all the way back down to 0. So that's why this is fairly straightforward. So that's e to the negative 0.05 t, and then that's minus 0.145. That's all dt. Okay, so we can simplify this to make life a bit easier for us. So that's going to be, we can take out the 100 because that's just itself, and e with a positive 0.03 minus 0.05, so that's going to be e to the negative 0.02 t minus 0.145, okay, dt, and then the integral of this, we take the derivative of what's up here, the index up here, and we divide the whole function by it. So that'll be actually 100 divided by negative 0.02, because there's no t's attached to that, we can just keep it on the outside, and we just keep the function by itself, 0.02t minus 0.145, and then whatever we find this to be, that's going to be our present value, what it asked for. So let's work that out in Excel over here, and we're going to say so that's equal to, firstly, 1000 divided by negative 0.02. I'll just leave that by itself. Sorry, not 1000, that's 100. So that shouldn't be 1000. I'll fix that up soon. So that was 100. And then we've got this bit. So we've got e to the negative 0.02 times t, which was 12, minus 0.145. And that was minus, again, e to the 0.02 times 10 minus 0.145. That gives us our answer there. So if we do this figure times this one, so outside of the brackets times what's inside the brackets, we have a present value of 138.85. Okay, so let's note that down. Sorry, just want to make sure, 138.85 pounds, and this was actually 100, so that's gone. So that's the answer to part 2, and now instead of making another video, let's just look at part 3. Calculate the present value of an annuity of £1,000 paid at the end of each year for the first 3 years. So that's just a regular annuity, except we're using this over here. So let's remember that, e to the negative 0.08, because we're within the time frame of 0 and 4. Okay, so I'll just do that further down. So there's that. Now we have, it was of 1,000, and we're doing A3, and we're just trying to find the present value there. So all that is it would be 1 minus normally v to the end, but instead we know that v is our, we've got e to the negative 0.08 to the n, which is 3, and then divided by, and we just have to divide it by I, and then we're going to times it by 1,000. Now, how do we find out what I is equal to? Well, we know that ln 1 plus I is e to the delta, so we know that e to the delta is 1 plus I, and therefore I is equal to e to the delta minus 1. And we know that delta is 0.08, so we'll just figure that one out when delta is 0.08, and remember that's a positive one because we just need I by itself. We don't need, because this bit's I, we don't need to do the negative there. So let's figure that out. So equals 1 minus e to the negative 0.08 times 3, that's the top half, and then e to the 0.08 minus 1, that's the bottom half. So we can divide them and then just multiply that by 1,000, and that looks about right. 3 payments of 1,000, so that'll be about 3,000 we'd have in the end, discounted back 2561.89. So sorry, everything just keeps flashing. Here we go. We have that was 2561.89, and that's the answer. That's how you solve that. And I also wrote at the top how many marks each one was worth. So I think 5, 4, and 3 marks for doing each of that. So thanks a lot for watching, and please ask if you have any more questions.